Welcome back to Inorganic Tutors Institute. In today's lecture, we are basically going to look at the concept behind divergence and curl of a vector field. Now, I want us to understand the intuitive concept behind divergence and curl of a vector field. So, first of all, I want you to imagine this, a fluid, okay? You have a fluid, okay? A fluid can be air or water, so pick one and let's do this analysis. Okay, so one that you pick, it's either flowing, okay? That particular fluid is flowing through a particular space, okay? Now, try to pick a point in space, okay? Pick a point in space and then imagine a very tiny balloon that is sitting at that point. Okay, so that very tiny balloon that is sitting at that point, if the fluid, okay, if the fluid flows out of the balloon, then we can say that the balloon what? Deflates, right? If the fluid flows out of the balloon, then we can say that it deflates. Now, the concept of what? Divergence over there is what? If the fluid is what? Flowing out of the balloon, then the divergence at that point is what? Negative. Okay, the divergence at that point is what? Negative. But if the fluid happens to flow in the balloon, then the balloon will be what? The balloon will what? Inflates. Okay, the balloon will what? Inflates. And at that point, the divergence is what? Positive. Okay, the divergence is what? Positive. So in a nutshell, divergence basically tells you how much a vector field is what? Spreading out or converging at a particular point. Let me take it again. At that point, or basically, or in a nutshell, divergence is telling you how much a vector field is spreading out, okay? Is spreading out or converging at a point or at a particular point. So now let's come back to a mathematical word, okay? So the mathematical definition of divergence So now, mathematically, what is a divergence? Okay, mathematically, what is a divergence? So basically, let's say that you have this vector field, okay? Let's say that you have this vector field F, and that vector field F is equal to this component, okay? P of X, comma Y, comma Z, or I, plus Q of X, Y, and Z, or J, plus R of X, Y, and Z, or K. This is the vector field of a divergence, right? Okay. So if you want to know the divergence of this vector field, then we defined the divergence as, okay, so the divergence of the vector field F is defined as change in the divergence field, change in the F, which is the vector field, okay? Change in the vector field equals First, if we have 2 dimension and we have 3 dimension, right? So if it is 2-dimensional, then it's going to be partial derivative of the first component, which is this, right? So if it is 2 dimension, then you are going to have, with the exception of this part, okay? So you're going to have partial derivative of the first component with respect to what? X, plus partial derivative of the second component with respect to what? Y. So this is 2-dimensional, 2D. So with the 2D, this is how you find your what? Divergence. If it is 3-dimensional or 3D, then you're going to have your divergence of the vector field to be partial derivative of the first component with respect to x plus partial derivative of the second component with respect to y plus partial derivative of the third component with respect to what? Z. And that becomes your what? Divergence at that point. So basically, what divergence does is what I've just explained to you. It's just tell you how much a particular vector field is spreading out or converging at a point. Okay, so this is a scalar function. Okay, this is a scalar function, not a vector function. Okay, it tells you the net rate of flow out per unit volume at a point. So although this result we have here, it is coming from a vector field, the output is a scalar function. Are you okay? So note that if you find the divergence of a particular vector field, you are going to have a scalar function. Okay, so now okay, so now we are considering this particular example to fully understand the concept of divergence. Okay, so this is the problem that we have. We want to find, or we want to know, the divergence of this particular vector field. Now, we have to check the component of the vector field. So to either know, to know whether we are going to use the 2-dimensional formula or the 3-dimensional formula, right? So in here, we can see that we have I component. We don't have any j component, but we have k component. That means that the j component is what? Missing, and it is what? 0. So we have, ideally, we have 3 components, okay? And that is going to call for the 3-dimensional formula. So recall that the 3-dimensional formula for divergence of a vector field is partial derivative of the first component with respect to x plus partial derivative of the second component with respect to y plus partial derivative of the third component with respect to z. Okay, now we've recorded the formula. Now, what do you have to do? If you are starting from the basics, I will advise that you take each component, then you differentiate. Take each component, then you differentiate. Then when you are done, you combine all to have your result. Now, we know that our P here is the I component, right? So the P is the I component, which is what? Y plus this s squared z, right? And the q is missing. So of course the q is what? 0. So the q is 0. And the r is equal to negative into y squared z plus 2xz, right? So we have been able to identify each of the components from the vector field. Now, what do we need? We need the partial derivative of the p with respect to what? X. Partial derivative of the q with respect to what? Y. Then finally, partial derivative of what? The r with respect to what? Z. So let's do that. So partial derivative of what? P with respect to x will be equal to y plus x squared z. So when you differentiate this with respect to x, when you are differentiating this, it means that the y will go towards 0. With respect to x, y will go towards 0 because it will be treated as a constant. Then we come to s squared z. When you differentiate s squared z with respect to x, you are going to have what? 2xz. So we're going to have 2xz. So we have the first component done. Now, we have to come to the second component. And we know that the second component, which is the q, is equal to what? The q is 0. So basically, we're going to what? 0. Okay. Left with the last part, which is what? The r. So partial derivative of the r with respect to z will be equal to partial derivative of what? Z of the r, which is negative y squared z negative 2xz, right? So this is what we have for the third component. Now let's try to differentiate that. Let's try to differentiate that. Okay, so when we differentiate this component with respect to z, we are going to have with respect to z, we are going to have negative y squared, then negative 2x, right? So with respect to z, we have this. With respect to x, we have this. And with respect to y, we have this. So we just have to combine all. So our divergence of the vector field f is equal to the first component we had what? 2xz. The second component we have what? 0. Plus the third component we have what? Negative y squared minus 2x. Okay, so we are going to have our divergence to be equal to 2xz minus 2x minus y squared, right? So we can see that 2x is common to the first two terms, right? So we can factor that out. So when we factor that, we are going to have 2x out, then z minus what? 1. Then we have minus y squared, right? So this is the divergence to this particular vector field. Okay, this is the divergence to this particular vector field. Very, very simple, right? So basically, if you are interested in the divergence of a particular vector field, this is what you have to go through. Okay, this is the process that we have to go through. So this is the three-dimensional vector field, right? So you have to get what? Three components. Okay, and we went through to have this. Now let's consider another example that will be what? A two-dimensional. Okay, once we are done, I'll give you some couple of trials so that you work with your hands on them, and I'll give you the final answer. this is what? This is a two-dimensional vector field, right? So it means that we are going to have what? Two components when we are using what? We are finding the divergence. So first of all, recall that divergence of a vector field, and specifically the two-dimensional, is giving us partial derivative of the first component with respect to x plus partial derivative of the second component with respect to what? Y. So what we need to do here is to identify our P and our Q. So our P here is the first component, right? So we have 2z squared. And the second component is the Q. Then we have Y. So we need the partial derivative of what? The first component. Then we need the partial derivative of the second component. So partial derivative of P with respect to x is equal to partial derivative of 2z squared, and that will be what? 0, because we don't have any x here. So it means that the rest of the content or the rest of the variables will go to what? 0. Now we need partial derivative of Q with respect to what? Y. Now our Q is what? Y with respect to what? Y. So this we are going to have what? 1. Right? When you differentiate Y with respect to Y, you are going to have what? 1. 1. Okay, so we have 1 and we have what? 0. So in all, our divergence of that particular vector field would be equal to 0 plus 1, and that is equal to 1. So we can see clearly that we have been given vector field, okay, which is a vector quantity, right? But the end product is a scalar quantity, right? And that is what? 1. Such is amazing, right? So welcome back from the break. Now I'm going to give you 2 trials, right? I'm going to give you 2 trials with the final solution so that you work your way out. Okay, so this is the first question. So trial 1, our question is let the vector field be f of x, y, and z, and that should be equal to x squared y plus z, or I, plus x, y, z, or j, plus e to the z plus x squared, or k, right? Our trial 2 is giving us f, the vector field is equal to, yz plus 3x, or I, plus xz minus y squared, or j, plus xy plus z cubed, or k, right? Now, I want you to find the divergence of these 2 vector fields. So Find the divergence of the given vector field. Now, these are the answers to the problems. Trial 1. Trial 1. The answer is equal to 2xy plus xy plus e to the z. And then trial 2. The answer is The answer is 3 minus 2y plus 3z squared. Okay, so these are the final answers to the trial problems. Okay, so this is trial 1 and this is trial 2. So please kindly go through the process and then get your final answer. Okay, make sure you go through the process step by step so that it will enhance your understanding. So that is the concept behind divergence. Now, let's have a very short break and come back for curl. Welcome back from the short break. I believe you have been able to solve the trial questions and you had the final answer, right? Interesting. Now, let's dive into the concept of curl of a vector field. You know, we have been reading the mathematical definitions, but the intuitive understanding behind curl is not really known. But here we are going to explain that before we go to the mathematical definitions. So I want you to picture this. I want you to picture this information in your head. Imagine that you have placed or you place a tiny paddle shell. Okay, you place a tiny paddle shell in a flowing fluid like we did earlier, air or water. Okay, now if the paddle spines, then the fluid has what? Curl at that point. If the paddle spines, then the fluid has a curl at that point. That is the concept. Now, if the paddle doesn't spine, then the curl is what? 0 at that point. If the paddle doesn't spine, then the curl is what? 0 at that point. Now, let's talk about irrotational. If something is irrotational, it means that your curl is basically what? Free. And if you have curl free, that means that the result is what? 0. That is the most amazing part of it. If you have curl free or irrotational, then it means what? Your curl is what? 0. That is all the concept. Now, you have to know conservative as well. So with the conservative, it's basically telling you that there exists a potential function phi. So that is when you'll be talking about changing the gradient times phi equals what? The vector field. That is basically all it's about with the conservative. So if you hear conservative, that means that that particular vector field is called what? The change in gradient times 5. And that is telling you that you have a particular potential function, which is what? Phi. So simply, curl tells you how much a field, or let's say, how much a field rotates around a particular point. How much a field rotates around a particular point. So now let's come to the mathematical understanding or the mathematical definition of curl. So we have, as we did in the divergence, we have the two-dimensional and the three-dimensional. So with the two-dimensional, we know that you are going to have only the I and J components, right? And that is going to comprise of the P and the what? Q. But with the three-dimensional, we're going to have I, J, and K, and that is P, Q, and what? R. So now let's look at the mathematical definitions well. So we are considering the three-dimensional, okay? So with the three-dimensional, let's say that you have this particular vector field, okay? F of x, y, and z equals pi plus qj plus rk. Now, the curl of this particular vector field is given by the cross product. So in here, we are using the what? Cross product, and that is going to deal with what? Matrices. So you have to respect the order. Okay, so the curl of this particular vector field is given by the cross product of the vector field, and that will be equal to I, J, K. Now, what you have to know is that once you have these components, then as we did earlier in the divergence, you have to take the first derivative, the partial derivative of the first component with respect to what? X. Then you take the partial derivative of the second component with respect to what? Y. Same applies to the third component with respect to what? Z. So you are going to take the partial derivative of the first component. So with respect to what? X. So we have P here, right? And the partial derivative of Y, or with respect to Y of the second component. Then you have the partial derivative with respect to Z of the third component, right? So basically when it comes to the curl, the result we get is what? A vector field, not a scalar field like in the divergence. No, for the curl, you still result in a vector field. Okay, so let's basically know the components of the curl. Okay, so we are going to break this matrix down so that we know the components of each of the curl, so that it won't be like at every point you have to construct this before you can be able to solve a problem. We are going to know the component for each curl. So once you have the vector field, you know where this is supposed to be, this is where this is supposed to be, and that is all we are here to do. So we are going to begin to break this down. So this is going to give us, matrices, right? I into, when you pick this, that means you cancel everything on this row, cancel everything below that particular element. So we only have this. So partial derivative with respect to y, partial derivative with respect to z, r, right? So minus j into, we pick this, break everything here, break everything here. So we have this with respect to x, p, then with respect to z, r, right? Then we come to the last component, which is k. So you take k, break everything here, break everything here. So we have this. So we have partial derivative with respect to what? X, p, with respect to y, k. Right? So this is what we have. Now let's try to identify the components, right? So we are going to have our kel, our kel, our kel to be equal to I into, this, we take this, right? So we are going to have partial derivative of r with respect to what? Y, right? Partial derivative of r with respect to what? Y, minus partial derivative of q with respect to z, right? So this is what we have, minus j into the second component, partial derivative of r with respect to x minus partial derivative of p with respect to what? Z. Okay. Now let's come to the last part, which is k, of partial derivative of k with respect to x. So partial derivative of k with respect to x minus partial derivative of p with respect to y. Partial derivative of p with respect to what? Y. Okay, so this is what we have. Okay, this is the breakdown at this point. Now, we can still simplify this so that we will get to know the components that goes for each of the KL. Okay, so we have our KL to be equal to the I component. We have I. So let's go like this. We have partial derivative of r with respect to y minus partial derivative of k with respect to what? Z or I. Then you know that this is negative, right? So if this goes, you're going to have negative here. So we have negative partial derivative with respect to r of r with respect to x. This comes here, we have what? Positive, right? So that becomes positive. Then we have partial derivative of p with respect to what? Z. And this is the j, right? Then we come to this, the k, which is going to be what? With respect to x minus what? With respect to y. Okay? So this is the k, this is I, j, and k. So I want us to make this clarification very well. You see, this is going to be what? The k will be equal to what? Partial derivative of r with respect to what? Y minus partial derivative of k with respect to what? Z or I. Then this is negative. This is positive, right? So let's bring this here and send this here so that it will be what? Systematic. So we have partial derivative of p with respect to what? Z minus partial derivative of r with respect to what? X. And that is j, right? Plus partial derivative of k with respect to x minus partial derivative of p with respect to y. and that is k. Okay, so we are going to do something. Okay, we are going to do something here, which is very interesting. So what you have to know, what I want you to know is that if you have a particular vector field, okay, so let me not clean the vector field. The vector field is what? Let's say f of x, y, z is equal to pi plus qj plus rk, right? Now, if you come here, you know that your curl is equal to, now the I component here is what? So the I component is giving us partial derivative of r with respect to y minus partial derivative of k with respect to z. Okay, so that is the I component. Are we okay with that? Now let's come to the j component. J component. So with the j component, we know that we are going to have partial derivative of p with respect to z minus partial derivative of r with respect to what? X. And that becomes the j component. With this, with the k component, we are going to have partial derivative of k with respect to what? X minus partial derivative of p with respect to y. And that is the k component. Now, this is not about memorization, okay? But once you keep solving problems, you will understand, and it will save you from going through from the scratch before you come to find the curl. So I want you to do this. I want you to know that if you are given a particular vector field, so this is a vector field, right? This is a vector field. And this is the I component, which is the P. This is the J component, which is the Q. And this is the the K component, which is the R. Okay? Now, when you are finding your Q, you know that the I component is first. You differentiate the K component with respect to what? Y. Minus differentiate the J component with respect to what? Z. And that is what is shown here. So what you have to know is that you don't have to go through the matrix process before you come and simplify and get this. Please make sure that you work more examples to keep this off head. So we are going to consider a particular example so that you understand what I'm trying to say. Okay, so let's have a short break and come back for a detailed example. Okay, so welcome back from the short break. Now, this is the problem that we have, and we want to find the curl. So we want to find the curl of this particular vector field. Now, this is the strategy. First of all, if you have a vector field and you want to find the curl, please identify your component. You know that the P is your I component, right? So you have y plus x squared z. Are we okay? Then your q is the j component, and in here we don't have any j, so that means it's what? 0. So we have 0. Then we come to the last part, which is the r. And you know that the r is the last component, which is what? The k component. So r equals negative into y squared z plus 2xz. Okay, so that is basically the R component is what? Minus y squared z minus 2x z. Okay, so once you have been able to identify the component of the vector field, then first, just have to remember this. The I component is giving us partial derivative of the R with respect to what? Y minus partial derivative of what? The Q with respect to what? Z. So this is what you need to get the I component of what? The Q. So what we are going to do is to differentiate this, then we get what? The I component. So partial derivative of R with respect to what? Y will be equal to, this is the R, right? So when you differentiate this very one with respect to Y, then you are going to have minus 2yz here. You're going to have minus 2yz because this, there is no y, so it means what? It goes to 0. So that is what we have. Now, we also need partial derivative of the second component, which is what? The q, with respect to what? Z. And we know that our q is what? 0. So basically, we are going to have 0. So this is what we have. Now, for us to get the I component, we subtract this, we subtract 0 from what? This. Okay, to get what? The I component. So we're going to have negative 2yz minus 0. And that is equal to minus 2yz. And that is what? The I component. Are we cool with this? I believe you are enjoying this strategy. So we have the I component. Now, we have to come and find the j component, right? So with the j component, we as well know that we need partial derivative of p with respect to what? Z minus partial derivative of r with respect to what? X. And that is the j component. So what we need here is the p and the r. Okay, and we've already obtained the derivative of what? Okay, so we have to find the derivative of p with respect to what? Z. And that is equal to, the p here is y plus x squared z, right? So when you differentiate this with respect to z, this will go to 0, and this here becomes x squared, right? So that is what we have for differentiating this. Now let's come to the second part, which is the r with respect to x. So we are going to differentiate this with respect to what? X. So negative y squared z, negative 2xz. Derivative of that with respect to z with respect to x is going to give us minus 2z, right? So this is what we need, right? So we have this and that. So for us to find the j component, we take this from this, okay? So our j component will be equal to x squared minus 2z, and that becomes s squared plus 2z, right? So that is the j component. Okay, now we have the j component, so we need to find the last component, which is what? The k. So we know that the k component, we only need partial derivative of the second component, which is what? The q. And then we need the partial derivative of the first component with respect to what? Y. So partial derivative of q with respect to what? X will be equal to partial derivative of the q, which is what? 0. And that is what? 0. Then we need partial derivative of p with respect to what? Y. And that will be what? Y squared plus x squared z, right? And that will be equal to 1, right? So we differentiate y with respect to y, you get 1. Then this goes to 0 because there is no y term. Okay, so we have that. So what we have to do is to take this from this. Then we have the k component. So we're going to have 0 minus 1, right? And that is the k component. Okay, so this is what we have for the k component. This is what we have for the I component. This is what we have for the j component. I believe this has been able to save some time because we didn't go through the matrix before we came to this point. We just have to record the formulas, then we are good to go. So we know that our curl, which is will be equal to the I component, which is negative 2y z or I, plus the j component is x squared plus 2z or j. Then the last component, which is the k, is negative k right here because it's 0 minus 1, which is what? Negative 1 times k, and it's what? Negative k. So this is what we have for the curl. Okay, now we have been given some points to evaluate that particular curl, right? So we have to evaluate the curl at that particular point. So at 1, 1, negative 1, right? We are to evaluate it at 1, 1, and negative 1. So our curl will be equal to negative 2 into y is 1, right? So y is 1 and z is negative 1, right? So that is the I component. Plus our x is 1, right? So we have 1 squared plus 2 into z is negative 1. So we have negative 1, right? Then this becomes our j component. Plus the k is already negative k, so we don't need to substitute anything. So we have minus k, right? So let's simplify this to have our final evaluated solution for the curl. So we know that when we evaluate this, we are going to have negative 2 times 1 is negative 2. Negative 2 times negative 1 becomes 2i. Then we come to the j component. We have 1 squared is 1 plus 2 times negative 1 is negative 2. So 1 minus negative 2 becomes 1 minus 2 becomes what? Negative 1. So we have minus j, right? So we have minus j. Then the last component, which is what? Minus k. Okay, so our curl is finally giving us 2i minus j minus k. I believe this strategy is very easy, right? So our curl is equal to 2I minus j minus k. That is so brilliant. So please just try to know the components, okay? Know the components for the curl, and then that will save you from going through the matrix before you come to, simplify the matrix and then put in the necessary derivatives. It's going to take you much time because we are dealing with time, okay? So know the components, know the I component, know the J component, and know the K component, and that is it. It makes work so pretty easy. Now, relax for some short time and then come back. I'll give you some couple of trials so that you give your hands or you give trials on them. I'll leave the final answer so that you check it out once you are done. Okay. Welcome back from the short break. Now let's consider this number of trials, okay? I'll leave the final answer for you to check it out once you are done with the process. So our first trial 1, is 3, our vector field is equal to 3x plus 2y plus 5z or I plus 2x minus 3y plus 4z or j plus x plus 6y plus 7z or k. So with this particular one, the final answer is 2i plus 4j. 2i plus 4j. So please, I want you to go through the strategic process and check your final answer to see if you have 2i plus 4j as your final answer. Now, the second trial is trial 2. I have f of x, y, z equals x squared z or I plus y squared z or j plus y k. So with this, I couldn't provide the final answer, but I believe you will go through the process and you get the final answer. Please leave your final answer at the comment section. I'll be very grateful to have a couple of answers coming up. Great. So that is the end of this lecture. The great news is that I've employed one great teaching assistant, okay, who is very tailored in the field of coding and analysis. Okay, so he's going to take this course, data analysis, okay, from the scratch to the advanced. So those of us who does data analysis and those of us who are not doing data analysis because of uh, uh, restrictions and all that, here is the good news. We are going to take data analysis from the scratch, from the basics to advanced, and it's going to help all students in UCC, especially MASAC students and the world at large. So prepare for it. But one exciting news is that all those taking data analysis, we are going to begin solving the last year's exams questions to help us prepare thoroughly towards our end of semester examination. That is amazing, right? So the initiative is titled Code and Analyze with Ease. Code and Analyze with Ease initiative. That is so brilliant, right? I'll welcome everyone, and please let everybody subscribe to the channel, and this initiative is going to help us a lot. This is going to be a bonus, profession for everybody, because today data analysis is a big time profession on its own. Bye bye for now, and on to the next video. Keep learning and stay inspired. Bye bye.